Now we will find third equation of motion. Okay, this is a bit complex method because it involves a lot of mathematical operations and mathematical calculations. So we will use both of the equations, equation 1 and equation 2, that we have already obtained so far, to reach and to find the third equation of motion. Now we have noticed that both our equations, the second equation, that was s is equal to ut plus half at square, and the first equation, that was v is equal to u plus at, it includes the time variable t. Both of them have t and t. Okay, so there will be some situations when we do not have information about time. So it would be a good idea to derive an equation that does not have a time t term. Okay, so to do this, we rearrange our first equation to get t is equal to v minus u divided by a. Where did this come from? It came from our first equation here. Okay, from here we have got the value of t. So t is equal to v minus u divided by a from this particular equation, all right. So we will use this to replace t wherever it appears in the second equation. So we will put this value of t in our equation number 2. This is our equation number 2. Okay, moving forward, this is our second equation of motion, and we will put the value of t here. This is the value of t. Okay, so replacing t by v minus 2 divided by a, we get s is equal to u, and we have replaced t by this ut plus half a t square. So again half a t is replaced by v minus u divided by a. Okay, now we will just simplify this equation. So we will start by taking a out of the squared bracket. Here we have a, so we will take it out. Simplifying, we get s is equal to u v minus u divided by a plus half into a v minus u square divided by a square. We have just separated out a. Okay, simplifying again, we have s is equal to u v minus u divided by a comes in its place again, plus half a square and a, so this gets cancelled by the square. Okay, so the remaining thing, we have half v minus u square divided by a. Now a and 2a we get common. Moving forward, we remove fractions by multiplying both sides of equation by 2a. Here we multiply 2a to this equation. So when 2a is multiplied on this side and on this side as well, so we get 2as is equal to 2u into v minus u, a gets cancelled, plus u minus v square. The 2a is multiplied, so it gets cancelled here. Okay, so we have final this equation, and we will simplify it further. So 2as is equal to 2u is multiplied with this thing in bracket, so 2uv minus 2u gets multiplied to u gives us 2u square plus v minus u square. So we use the formula a minus b whole square is equal to a square minus 2ab plus b square. See, v minus u square is simplified and we get this. So now the next step, 2as is equal to 2uv gets cancelled with minus 2uv, and minus 2u square plus u square gives us minus u square, and v square comes on its place. So 2as is equal to v square minus u square. V is the final velocity and u is initial velocity. We can also pronounce this as 2as is equal to vf square minus vi square. Vf is final velocity and vi is initial velocity. So this is our final equation, which is third equation of motion. V square is equal to u square plus 2as. V is the final velocity, u is initial velocity. A is acceleration and s is displacement. So we can say final velocity square is equal to initial velocity square plus 2 times acceleration multiplied by displacement. Okay, thank you. And we have derived all the 3 equations of motion in this lecture. Furthermore, subscribe to my channel to get more videos on acceleration, velocity time graphs, position time graphs, mechanics, and further physics videos. Thank you so much.